All right, let's look at the homework 3.7, problem number 10. All right, so let's sketch the graph. Before we sketch the graph, we should find all these other things first, right? All right, so let's find the x-intercept, right? So x-intercept and also y-intercepts, all right? So let's do that. All right, so let's find x-intercept. Whoops. All right, so if you want to find x-intercept, what you want to do is you want to set y equals 0, right? Then we have, 0 is equal to, all right, I'm going to take the common denominator. So we have x plus 32 over x squared, right? So since I want to have x squared on the bottom, so what I'm going to do is I'm going to multiply the first term by x squared over x squared, right? So that way we're going to have x squared is the common factor, common denominator. So I'm going to put x squared there. All right, then you have x cubed. All right, and then plus, actually x cubed, and then we have plus 32. All right, so we have that. All right, so we set that equal to 0, and here. All right, then we know that, so since the numerator has to be equal to 0, so we know that x cubed must be equal to negative 32, right? All right, so we can take the cube root of both sides, then x is equal to cube root of negative 32. All right, so we got the x-intercept, and let's find the y-intercept. All right, and unfortunately, we wanted to set x equals 0, but x will make this function undefined, so you know that, so there's no y-intercept. All right, so let's type it in here. All right, so we have x-intercept is cube root. Let's we have to find a cube root here. Functions maybe, yep. So we have a cube root of negative 32, comma 0, and a y-intercept does not exist. All right, we have that. All right, let's check the answer. All right, I came back and looks like the system didn't like my answer. All right, another thing I can think of is I'm gonna put the negative sign outside. All right, let's check it again. Let's check the answer. All right, it came back and I guess that was it. It took my answer for x-intercept and the y-intercept does not exist. All right, so next one, we need to find the local maximum and the local minimum. All right, so let's do that. All right, we need to take the derivative. So I'm going to rewrite this function as x plus 32 x to the negative 2 power, because x squared is sitting on the bottom. All right, so if you take the derivative y prime, you're going to get derivative of x is 1. And derivative of that would be put the negative 2 in front, so negative 64 x, and then subtract 1 from the power, so it's a negative 3, right? So that's the derivative. And if you want to find a critical number, we're going to do, let's see, I'm going to do, write it as a fraction form. 1 minus 64 is on top, and then you have x cubed, right? Then we're going to just take the common denominator. So you have x cubed and the x cubed there. Then we can write it as So we have x cubed is on the bottom, so that's the common denominator. So we circle those. All right, then we have 1 times x cubed. So you have x cubed, and then minus 64. So I'm going to subtract 64. Right? So if you set that equal to 0 to find a critical number, we see that, oh, actually, I messed that up, x cubed, right? All right, x cubed must be equal to 64. And then if you take the cube root of both sides, x is going to be equal to 4. Right? So this is a critical number. Right? Then what we want to do is we want to see if this is going to give us a local max or local min. Right? So we're going to do a number line. Right? All right, so 0, the function is not defined there, so I'm going to put an open circle there. All right, so we have a 0 there. All right, then we need tick marks for 4, so we put that there. All right, then we just have to find the sign of y prime. All right, any number less than 0, I'll try x equals -1. Between 0 and 4, x equals +1. Bigger than 4, x equals 5. All right, so let's look at the sign. All right, if you plug in -1, right, -1 minus 64 is going to be negative, and the denominator is also negative, so negative divided by negative is actually positive. Right, and if it's 1, so 1 minus 64 is negative, and then over positive, so it's going to be negative here. Right? If it's 5, 5 cubed is bigger than 64, positive divided by positive, so this is going to be positive. All right, so we know that the original function is increasing before 0, decreasing before 0 and 4, and increasing after 4. All right, so we know that the critical number there is going to be, if you look at the shape, you're looking at the bottom of the valley, so we know that it's going to be a local minimum there. All right, so let's find the corresponding function value. Y of 4 is going to be equal to 4 plus 32 over 4 squared is 16. So it's going to be a 4 plus 2, so 6. All right, so 4, 6 is the local minimum. All right, so then, right, so you have local minimum is 4, 6, and then we do not have a local maximum, so we put does not exist. All right, let's check the answer. All right, I came back and looks like we got the local maximum and the local minimum correctly. All right, let's look for point of inflection. All right, so here, this is the first derivative, so I'm going to take another derivative to find the second derivative. All right, derivative 1 is 0, and put the -3 in front. All right, -3 times -64 is what? 3 times 4 is 12, and 3 times 6 is 18, so 192 x to the minus 4 power. All right, so this is the same thing as 192 over x to the 4th power, which is always positive. Right, which means that it's always concave up, which means that there's no inflection point. All right, so I'm going to just go ahead and answer that. No inflection point, so I'm going to put does not exist there. All right, then vertical asymptote, you can see that here, when x equals 0, it's going to blow up. So x equals 0 is the vertical asymptote. All right, and the horizontal asymptote, but you can see that here, if you, actually, I'm going to go here, all right? If you write it in this notation here, you can see that you have a higher power on top and the bottom power, so which means that there is no horizontal asymptote using the trick that we learned in class. So horizontal asymptote does not exist. Right? and state the domain of the function. So it's going to be only bad number is x equals 0, right? So you have a negative infinity. So I'm going to do a symbol here all the way up to 0. And then we have to skip 0. So I'm gonna use a set notation here. And from 0 to positive infinity, right? So we got that. All right, let's check the answer. All right, it came back and looks like we got part C and the rest of the part B correctly. All right, and then we have to pick the right picture. All right, so let's see. So we have an x-intercept at the negative cube root of 32. All right, so this one has a negative x-intercept here. This one doesn't, and this one does. This one doesn't. So we know that it's either a third picture or the second picture or the third picture, right? And then we have a relative minimum at the 4,6, right? Relative minimum, so this seems like this is a relative maximum here. And here, this looks like a 4,6 where the minimum is, so this is the correct picture, right? So if you look at that and all right, it came back and that looks like we got the correct picture as well. So this is the correct picture. All right, that's it. I hope that this was clear.